Yes, I was discussing about the concept of Mayard again, Mayard twice. So, what was the concept? I would like to let you know. Our concept is that some patient receives a treatment of relaxation, and before taking that treatment of relaxation, the number of asthma attacks were recorded, and some of the patient, their condition doesn't change, some of the patient improved. So how can we analyze this data? Because first of all, we need to check whether the data is parametric or normal or not. So the procedure is same, we are repeating again and again. So go to analyze, go to just a minute, are we recording it? Yes, I think we are recording, already recording. Yes, we are recording. So you need to go to analyze, go to non-parametric, go to one sample, then legacy dialog box, and then you need to choose one sample KS. Whenever you need to apply the mean comparison testers for the purpose of checking the normality, you need to apply one sample KS for normality. So remember this thing, that for the purpose of normality, we need to have a data in this shape, like there are two columns, before and after. So we need the difference value. How we can calculate the difference value if difference is not available? How you can calculate it? Let's suppose that we have only before and after data, and we doesn't have the difference value, because we need a single value to analyze the normality of that data. So you go to the transform, compute variable. Here you need to create difference, and it is very easy. Just you need to double click before, click minus from here, and then you need to double click after and click OK, and you will see the file. Just need to check it. I think it is open. We need to close it. Yes, we need to close it too. All right, the difference column has been created. So we need a single value or representative, that is the representative of both of them. So we need to go to analyze button, and then we need to check legacy dialog box and one sample KS, and we need to put this value because we have two values, and for the purpose of normality, we need to put a single variable which is the representative of the other two. So difference is here. Just click OK, and you will see a table like this. Here you can see asymptotic significance two tail value is greater than 0.05. So we can conclude that our data is normal and we need to apply parametric test. So I have told you that we have two options. If our data is normal, we need to go for paired t-test, and if our data is not normal, we need to go to the Wilcoxon sign test. So here is the procedure that I am using for SPSS for testing the normality: analyze, non-parametric test, legacy dialog box, one sample KS, put your sample data into test variable list and press OK. If asymptotic sig value to tail is greater than 0.05, the data is normal. You need to choose parametric test, which is paired sample t-test. And if your asymptotic sig value to tail is less than 0.05, the data is not normal. You need to choose non-parametric test, which is Wilcoxon signed rank test. So what you need to do, you need to go to this procedure that I have already elaborated in front of you, and we find out that our value is greater than 0.05. So what we conclude over here, we conclude that our data is normal, and we need to use a paired sample t-test. That is our interpretation. So what is the next procedure? We need to go for one sample, sorry, paired sample t-test. So how can we do it? Just go to your file, your SPSS file, go to analyze, go to compare means. That is when you need to compare whether it is one sample t-test, two sample t-test. So we need to choose here from here the paired sample t-test because our data is normal. So we need to choose paired sample t-test. Just click it. You have a file for asthma attack before the intervention, and you have a file for asthma attack after the intervention. So select before. For first variable, you need to check it and you need to put it as a first variable. Before should be put into first variable, and you need to choose after, and you need to put it as a second variable. There is nothing you can do anymore. Just click OK, and you will find this. There are three tables. There are four tables actually. You are seeing over here. There is paired sample statistic. There is paired sample correlation. There is paired sample test, and there is paired sample effect size. The only thing that we need over here is paired sample statistic and paired sample test. So what we need to see over here, first, in paired sample statistic, we need to see the mean value. Before the treatment, before the relaxation treatment was provided, the mean value of asthma attack was greater. And after the treatment was provided, after the relaxation treatment intervention was provided, it was decreased to 2.20. It means the number of attacks that were previously 5.40 has decreased to 2.20. It means that relaxation training that was provided is very effective because it has decreased the asthma attack into the patient. The next thing that we need to see is paired sample test table. Here we can see the average difference mean value. How There was again an interruption from the internet, but don't worry. Today is basically the New Year night. That's why the network is interrupting again. But I am sharing the screen again. I was telling you about these table. You need to check only the paired sample statistic table, and you need to check the paired sample test table. So I have elaborated how paired sample statistic you will interpret. You can say that before taking the relaxation training, the mean or the average asthma attacks the patients were suffering from was 5.40, and after taking the training, after taking the relaxation training, the asthma attacks were decreased. So it's mean what we can conclude here, that we can conclude that the training is very beneficial for the patient. So the patients are advised to take regular trainings, so to increase their asthma attack. And next we need to see the paired sample t-test. Here you can see the mean. I was telling that this mean is computed by subtracting the mean value of after training from the mean value of before training. So when we subtract 2.20 from 5.40, it will become 3.20. It is the mean difference before and after. Next, we need to check the t value. If the t value is greater than 1.96, it's mean this difference is significance difference. And you can also see the sig value, which is less than 0.05. So we can conclude that there is a significant positive difference between the training before sorry between the asthma attack before training and after training. So there is a significance difference. There is a significance positive difference between the asthma attack before sorry because this is decreasing. There is there is a significant negative difference. We can consider it negative because it is decreasing. Before the value was 5.40, but after its value is decreased 2.20, so we can say that this mean value is the negative difference. So we can say that there is a negative difference, or the mean difference between the asthma attack before and after the training has significantly decreased. So H naught is rejected. You need not to interpret the paired sample effect size and paired sample correlation. You just need to interpret the first table and the third table. So this is the way we can interpret this table. The same procedure is applied over here. I would show you. You can see over here. I have done all this procedure, and we came to know these are the values. Like I have told you, in the first table you need to see the mean value, how much was before and how much was after. And in the third table you need to see whether the mean value is positive or negative. Then you need to see the t value and sig two tail value. If it is if the t value is 1.96 greater than 1.96 and sig value is less than 0.05, it means this difference is significant and we are rejecting the null hypothesis. So how we interpret this? There is a significance difference between before and after intervention or training. So this is basically the interpretation. And you need to check for example 6. You have a data regarding example 6 in the form of Wilcoxon. I would let you know. There is a data set with the name Wilcoxon paired sample. I would like to show you how it will analyze, and you analyze it. You need to analyze this data set as a drill. At first, you need to check the normality using the same procedure we have used. Check the normality first in using the same procedure I have defined you. Then it will become not normal. Then you need to choose Wilcoxon signed rank test. And how will you find out it? You just need to go over here, analyze. Uh, you can see there are some tests over here. These are basically, you can say, these are the parametric tests. You need to go to non-parametric test legacy dialog box, and there are two related sample. There is two related sample. You need to choose it when your data, and you need to go there and you need to provide before and after and so on. And you need to choose Wilcoxon signed rank test. All right. And then click OK. So try to complete this drill as per your own. I would like to again let you know, you need to go to analyze, non-parametric test, legacy dialog box, one sample ks for normality test. And when you done it and it is proved that the data is not normal, then you need to choose two related sample. This is basically Wilcoxon signed rand text when your data is not normal. So you need to click it, you need to put before and after data, and you need to choose sign and click OK, and you will see some results. So this is the procedure, and this is the end of today's discussion. So I need the feedback of you all people, and I would like to say happy new year to all of you. So if you need to provide me any feedback? Do you have any question, or do you want to discuss anything? You can discuss. People are saying that they can't hear me. Uh, Please let me know if you people didn't hear. I can hear you. All right. Anybody else?
Evening, sir. Earlier it was a problem. Now it is okay, sir.
All right. All right.
Thank you.
Any question? Any question from the audience, or just or we conclude this session?
Sir, no, each and everything is clear, sir. Thank
All right.
you.
All right. Let's see how many were present over, so we can conclude. So these were the participant for today's discussion at the end of the session. So I would like to conclude. This was a wonderful session for today, and I will discuss two group mean comparison on Friday, on the coming Friday, and I will discuss more than two groups mean comparison on Saturday. They were also detailed topic. I need to see some of you have shared data. Yes, it is greater than 0.20. It is still normal. It means we cannot apply not normal data. Did you use the data provided by me? You need to check it. Yes, sir. All clear. It has been beautiful session. I have missed few points due to poor internet connection. Don't worry if you missed anything. The recordings will be provided as a link. You can share, and even you can download it from the site where the link has been provided. You can download it. So don't worry. So we need to check whether this issue is here. So I will provide some refined file to you for your practice. Till then, happy new year from me, and enjoy your last day of 2023, or perhaps the last night. So thank you very much, all of you, and happy new year. Thank you.
Thank you, sir.
Welcome, Evelyn.
Thank you very
Thank
much,
you.
and
Thank
Happy
you.
New Year, everyone.
Thank you. Thank you. Happy New Year to everyone.
Thank you. Thank you, everyone. Thank you, everyone. We will meet again for the next session on Friday, coming week Friday, on 5th December. So we will move forward from that day. Because these training sessions will be provided on every weekends, on Friday, Saturday, and Sunday. So we will meet again on the coming Friday next week. All right. All right. Good day, good night, and happy new year again. Thank you.